Okay, great. So now we're recording. And let's talk about introduction and kinematics review. So look at number 1. Know about scientific method, units, fundamental units, unit, prefixes, precision, accuracy, significant figures, vectors, scalars. So if you look at your notes, that's probably the best thing to do to help you study. So if you just click on, well, I'm on my Dropbox, but if you go to Schoology and click on problem sets and click on solution keys, you see everything there. And if I click on my Dropbox folder, yeah, so it just kind of goes over all the basics. And then there's some other stuff on vectors and stuff like that. So anyway, review your notes. I think that's important for those kind of problems. Convert, just so you know, that's terameters. You might have heard terabytes. So there's like megabytes, gigabytes, and then terabytes. I don't know if I'll ask that question, but no, just make sure you're comfortable with conversions. Just, 1 terabyte, or terameter actually, sorry, focus on memory for a computer, is actually 1 times 10 to the 12th meters. So remember, mega is 10 to the 6, so kilo is 10 to the 3, mega is 10 to the 6, giga is 10 to the 9, and tera, actually I should double check that. I'm pretty sure it's 10 to the 12th. Yeah, 10 to the 12th. So obviously if I'm converting 1 terameter, 120 terameters, 100 terameters, or 1 terameter is 1 times 10 to the 12th meters. And it's 120, so it's actually 1.2 times 10 to the 14th meters. So anyway, very basic there. Number 3 is kind of talking about direction. So you go 120 meters due east, turn around, then you walk 20 meters due west. What is the displacement? Obviously, it's 80 meters east, but you travel 120 meters because you have 100 one way and 20 the other way. So if you're running like a Fitbit or a device that kept track of your steps, your motion, you walk 120 meters, but your displacement's 80 meters east. And if you look at the answer key, I think they would probably, yeah. So you can kind of see they compute that for you. So that's just good review. 4, pigeon flew 10 kilometers across town, the average speed 5 meters per second. How long? I mean, that's just pretty easy. That's just distance equals rate times time. So there's velocity. You did to convert the 10 kilometers, however, and velocity is change in distance over time. You solve for the time, it takes 2,000 seconds. Convert that to hours, get 0.56 hours. So it wasn't as simple. I'll kind of walk you through that again. It wasn't as simple as D equals RT, but kind of is though. I mean, again, 10 kilometers is 10,000 meters, and your rate's 5 meters per second. So your time is just 2,000 seconds. And then you guys convert that to hours. That's easy. 2,000 seconds. And then boom, 1 hour, it's 3,600 seconds, easy peasy, right? No problem there. 5, remember how those problems work? Starting from rest, accelerate to 2 meters per second squared. How far will the car travel in 10 seconds? Remember, our final velocity is your initial velocity plus our acceleration times time. Remember, this is part of our formula sheets on kinematics, which is right here, velocity equals initial velocity plus AT. So you guys should be pretty comfortable with that. Just plug it in and work it out. I'll let you guys do that one. If you look at 6, the minimum takeoff speed for a certain airplane is 50 meters per second. What minimum acceleration required the plane must leave a runway of 2,000 meters. So the plane starts from rest. So in this case, we're going to use a formula that involves a distance, and time is irrelevant. Remember, you kind of figure out whichever one's irrelevant. We kind of did a little table a while ago. So if I look back at my formula sheet, I see that time is not included in this formula. I do have x minus x0 as displacement, a acceleration, which I'm trying to find, I believe. Initial velocity, which I know is 0. Final velocity, trying to get to 50 so that we can take off. And time is irrelevant. So obviously we're using this formula, v squared equals v0 squared plus 2a x minus x0. So you're doing 50 squared equals 0 squared, of course, goes away, plus 2a times 2,000. And you kind of just work out this bad boy. So let you guys work that out. 7, water drips from rest from a leaf that is 2 meters above the ground. The growth of air was the speed of each water drop when it hits the ground. Remember, if it's dropping to the ground, your acceleration is going to be 9.8. And actually, we'll probably say it's negative 9.8 because it's pointing downwards. Assuming it's starting from rest. So, and again, we don't care about time. So you can use the same formula we did for 6. And so that will help you get the velocity for that one. What maximum height will be reached by a stone thrown straight upwards? So you have your initial speed. Your final speed is going to be 0, however, right? Because it does stop momentarily. So let me kind of work that out for you guys there. So that's a different formula. Actually, not really. So v squared equals v0 squared plus 2a x minus x0. Final velocity is 0 squared. Initial velocity is 5 squared. And acceleration is working against you, right? Because your velocity is going up when you throw it upwards, right? So your acceleration is working against you. It's negative 9.8. And you try and solve for this. So be mindful of the signs and the directions you're dealing with. So that's negative 25 on this side. That's negative 19.6. And if I work that on my calculator, remember you want a positive distance, right? 25 divided by 19.6. You get about 1.28 meters per second. Remember, I'm keeping everything multiple choice. So should be really, really easy. And again, if you look at the answer key, yeah, exactly what I got. So it's nice. It kind of works it all out for you, gives you the equations. I use x minus x0, y minus y0, it doesn't really matter. So but I did work out 8 with you guys. I want to try it again. 9, the cheetah is walking at a speed of 0.5 meters per second. Observe the gazelle 50 meters directly ahead. Cheetah accelerates 3 meters per second squared. How long? That's time. So in this case, the final velocity is irrelevant. So I want to use some of the initial velocity, time, distance. The gazelle doesn't move. The gazelle is probably totally impervious to the surroundings, I guess. So I'll be using this formula now. You can bring the x0 over because you probably see in the initial position of the cheetah is 0, but you want to get to a position of 15 so it can eat the gazelle. The initial velocity of the cheetah was 0.5 meters per second. And obviously it accelerates really fast, 3 meters per second squared. And then you're trying to solve for time here. Cheetahs, I believe, move really, really fast. I think they're the fastest land animals on the planet. Yeah, top speed is 58 miles per hour. Yeah, it is considered the fastest land animal. And if you actually were to convert that to meters per second, yeah, about 26. So it can get pretty darn fast. For 10, be able to read graphs and calculate. Yeah, just know how to do that. And probably, again, reviewing your notes would be good. I think we did kind of graphical stuff. Yeah, there we go, velocity and graphs. So just review your notes, just make sure you're comfortable with understanding all that stuff there. Let's see. Excuse me. 11 jumper, and the long jump goes into the jump with a speed of 5 meters per second. Angle 20 degrees above the horizontal. What is the jump's horizontal speed? So you're just breaking it down. Remember, do a right triangle. That's 5, and you got 20 degrees right there. So that's Vx and Vy. And so, yeah, cosine of 20 is Vx over 5. Cosine of 20 is Vy over 5. Just solve for that. It's easy. I removed 12 because we didn't really do stuff like that, and 13 and 15 as well. So don't worry about 12 and 15. I didn't highlight them for good reason. 13. Eagles find due east at that speed, carrying a gopher in its talons. Gopher manages to break free at a height of 50 meters. Was magnitude of gopher's velocity as it reaches the ground. So what I suppose you could probably do is that's probably going to be its initial velocity in the horizontal direction. So that one's going to be a little bit, I think, complex. I'm going to kind of help you with the setup there. So take good notes here. So if you kind of think of the vertical velocity, right? So the vertical velocity will be this. We'll use y minus y0 because it is a vertical. So here's, the bird with his talons. Okay, it's actually a pretty good looking bird there. Gopher, there's a gopher, not happy. He drops, right? Anyway, so I'm using y minus y0. But if we find the vertical velocity, that's going to, you're going to be assuming the vertical velocity is initially 0, and gravity negative 9.8, and it's actually the initial position is 50. The final position will be 0, so you make that negative 50. So you can get the final velocity in the y direction. The velocity in the x direction is not going to change because there's no acceleration in that direction. So that's just going to stay as 5. And remember, your final velocity is going to be the combination of these two here. We didn't quite do enough of this stuff, so I won't ask this in the final, but still good practice to find what Vy is. And then knowing that Vx is 5, you can plug into that formula to find the actual true velocity. It is in the formula sheet, I just didn't highlight it. It's actually right there. But that's how you would actually approach 13. And then 14, a ball is thrown horizontally from the top 100-meter building with no speed of 5 meters per second. How far from the base of the building to the ball land? Now that one's a good one. So again, your initial vertical velocity is 0. Your final vertical velocity, that obviously will be different. Acceleration due to gravity, of course, is negative 9.8. You're 100 meters from the building. So you're going to be using a combination of things here. So 14, again, take good notes. Your Vx is going to be your change in displacement times time. And our Vy, we're going to do the same thing as we did for 13. So initially, there's no vertical velocity because ball's thrown horizontally. And that's just going to be 0 squared plus 2 times negative 9.8. And times 100. Give me one sec here. Actually, I'm not sure if I want to use that formula. Actually, I don't want to use that formula because getting Vy is actually useless. What I do want to do is I want to find the time, because I do know the horizontal velocity is going to be 5. That stays the same. I want x minus x0, how long it travels, but I do need time. So I'm actually going to use this formula instead. Y minus y0 equals v0 in the y direction times time plus 1/2 at squared. Again, you have no velocity in the y direction, so that just goes away. You're doing negative 9.8 t squared. And initially, your position is 100 off the ground. You're going to get down to the ground, which is 0. So negative 100 is going to equal negative 4.9 t squared. Solve for t, throw into here, and then you'll solve for how far it lands. That's one I could ask in the final. I like 14 a lot. 14 is a really good one. So anyway, so I'm going to have you guys get to work. So you guys are going to do 5 through 14. Kind of explained how to do, except 12 and 15, obviously. But I did kind of explain how to do 1, 2, 3, 4. 10, actually, not really doing anything with that. So really, you're just doing this. And I kind of already did some of these problems for you anyway. But you're really doing 5 through 9. 11, and 13, 14. So if you do a quick count, that's a total of 8 problems. Some of these problems should be pretty quick. I'll give you guys about 20 minutes. I don't think you need that much more time than that. We'll try to come back at about 11, I don't know, 11:10 or so. And now I'll talk about the next unit, kind of do some sample problems, and then we'll do a lunch break after that. But let me put you guys in breakout rooms. I'll set for 20 minutes. So again, you're doing unit 1, trying these problems here, 11, 13, 14. So I'll stop sharing.